This week, we are looking at Module 11. It's going to be Lab 18 and 19, and these exercises come straight out of the lab manual. It is Exercise 24 and Exercise 26 in your lab manuals. And potentially more so than any of the other labs we have looked at thus far, the information that you need to effectively complete these labs is going to be resting within the supplemental reading that exists in those labs. So specifically for exercise 24, it is going to be imperative that you spend some time reading through the supplemental reading, looking at those graphs, as this is going to help to get you to understand exactly what you're looking for and help you to analyze the types of graphs so that you can successfully answer the questions not only in the practice lab, but obviously in the graded lab. So for this, I've gone ahead and broken it down separately. I'm going to give you the quick overview of what you need to know and what you need to do in order to do the lab before I give you a little bit more additional information you will find throughout the supplemental reading. So first, it's what you need to know in order to complete the assignments, and then if you'd like more information, listen to me lecture about the information that is presented to you throughout the supplemental reading, then you can watch the rest of the video. But let's go ahead and jump right into it. So first things first, as I mentioned, it is imperative that you open up your lab manual, again, starting around page 165. You really need to pay attention to these two graphs, as these are the figures, I should say, that you're going to be needing to analyze and answer questions off of. So two new words that you may not be familiar with just yet are glaciation and interglacial. So glaciation refers to a time where it was cold, and interglacial means that these are times between periods of glaciation, meaning that it is going to be warm. And so when we're looking at the temperatures of Earth that go back over 800,000 years, you can see how 0 degrees, right? It gets cold and it gets warm. So you can tell that where it is warm, these are peaks of interglacial time, versus when it gets cold, this is when glaciation occurs. So you will have to identify, accurately analyze these graphs and the data that it is showing you, and the relationship between the carbon dioxide as well as global temperatures. In addition to that, you will need to be paying attention to this other graph. There's going to be quite a few questions coming from this figure, and most importantly, that's why I've added it, or added the description for this figure in here, is that the average annual temperature in these three different cities, Tucson, Bozeman, and Nome, are going to change. And so what's really important is that you have to pay attention to the individual data points, data lines that are being displayed for you here. So we have a 5-year moving average shown with this thick trend line. That is going to be this really thick black line that's showing you the average change in temperature. A best fit shown with the thin straight line. So this is the overall average throughout these years. So the black line is the average from the individual temperatures shown from year to year, or collected from year to year. And the thin line is going to be the best fit line. So you need to keep that in mind as you go through and answer these questions. In addition, and I've blown up the Arctic temperature one, that the time scale for each of these lines is a little I don't know about counterintuitive, but it's important to note that when you are making calculations trying to figure out the changes in temperature and how long it has taken to make those changes, just be aware that the distance between these lines is 40,000 years. And so again, I've blown up this figure just so you can see the differences in what the data is showing you. We have the points for the temperature for each individual year, so you're going to have to identify that. The 5-year average is that thick line where they're taking the average temperatures that are collected from a year-to-year basis, and they're making a 5-year average. That's that thick black line. And then the best fit line is averaging out all of these points over time so you can see the general trend of how temperature is changing. So clearly in this example, you can see how temperature has been increasing over the last, over 100 years. I need to point out that while you are working on your labs, there are a couple of questions that you need to keep in mind. So this is a question that's coming from the practice lab. This is question 2. And you will have to keep this question in mind and the answers that you get from these questions in order to answer a question on the graded lab. So jumping back over to the graded lab, this is referencing question 2. There's going to be additional information as where you need to find the question or the information that you're looking for in order to answer the questions. But most importantly, you have to read the heat island section and you have to be referring back to that in order to just do a little bit of math. So keep that in mind. I would also recommend that as you are working with your lab manual, write the answers into the lab manual so that you can always refer back to them rather than just answering questions through the learning management system. So again, keep in mind that when you get to question 5 in the practice exercise, keep those numbers handy because you will need them in the graded lab. So that's pretty much the minimum amount of information I think that you're going to need in order to do well on the practice and graded labs. If you would like additional information, again, I will just go into a little bit more depth about the weather variability and climate change information that you can find in the supplemental reading. If that sounds interesting to you, then stick around and I'll go over some of that information. Otherwise, I think you can probably pause the video here and see if you want to tackle the practice and graded labs by yourself.